Hello, how are we doing here today? This is a very comfortable place to sit, I must admit. And I wish I was seated there as well. Thank you for choosing to sit here with me. I know we have a couple of options. There's three different rooms to be seated from, and he chose to sit with me. I have a hell of a lot of content to go through, but first we need to make sure we're friendly with one another. We need to be on the same page. And I do this, typically, I've done it a million times, by presenting three distinct statements. And I want you to respond to that. That could be agreeing, that could be disagreeing. And you can do that visually by raising your hand or nodding. You can do that very verbally as well. We're among friends. Could get a bit rowdy, can't it? Lovely ladies and gentlemen here at the Everyman Theatre, Canary Wharf, London. Are we ready to start interacting? Can that work? I have a really bright light in my face. I can hardly see it. Yes, but I have to do that. Yes, okay, wonderful. Ladies and gentlemen, do we agree that slow websites suck? All right, that's a good one. It's an easy one, right? That usually works. Second one, do we agree that web performance is an essential part of the user experience? Yeah, it's a competitive market. If you're slow, people go elsewhere. The third one is usually slightly more controversial, and I get a lot of yays, nays, and mehs for it. So here it goes. Do we believe that a slow website is just as bad as a website that is down? Ooh. Yeah, I see disappointed faces. Let's stick with the consensus here that I see throughout. It's meh. But regardless of your nose or mess, here's what's going to happen when you are slow or down. It's irrefutable. You will lose money. You will lose face. Might even lose a little bit of Google PageRank in the process. It happens. So how do we mitigate it? How do we approach this? A lot of people say a slowdown is probably the direct result of a capacity issue. Let's start throwing servers at the problem. A lot of people do it, right? A lot of people see that as that symptomatic behavior. And I can't deny it. When the house is on fire, you need to do firefighting. This is a valid solution in the short run. In the long term, it's not sustainable. You're just throwing money at the problem. And as the famous poet, Notorious B.I.G. once said, "Mo money, mo servers, mo problems." So let's just believe the guy, shall we? So that technique doesn't work. What else can we do? We could do the sensible thing of identifying the slowest parts, looking at what's slowing us down, and just plain optimizing it. Bottom up, top down, you choose. Go all the way from the data center to which cooling systems you have in the data center, to the infrastructure, to the operating system, the system dependencies, the way you tune your kernel, your application runtime, your code, the way you access databases, the HTML that you output, or the way that you format your images. Up to you. And I'm pretty sure you'll get some gains, some decent gains, but you can't optimize yourself out of a scalability issue. In the beginning, you'll get lots of gains, but after a while, you'll hit that point of so-called diminishing returns. So what do we do? Last time I asked it. The answer would be, we will perform some caching. And that is what we're going to talk about today. So I love using the metaphor of boxes because we're doing nothing more than storing pre-computed results in boxes for later use. And if we approach it from a more philosophical side, like why wouldn't you? Why would you completely recompute the data and access the database and send it to your runtime if the data simply doesn't change? Why would you do it? That's the topic of today. And that being said, hi everyone, my name is Thijs. Pleasure again to have you here. Thijs, it's not a British name, is it? Nor do I have a British accent. I'm a Dutch-speaking Belgian, and I'm the tech evangelist for a company called Varnish Software, the author of, look at me, slightly meh, slightly disappointed, the author of Getting Started with Varnish Cache. The reason I'm not excited is because it's an old book. I still get royalties for it, but don't buy it. Don't do it. It's old. It's outdated. Rather, get this one, Varnish 6 by example, my magnus opus during COVID. The lockdowns were long. It's a big book. I have a free copy to hand out. I'll leave it here. We'll figure that out later. We can distribute it. One thing's for sure, I'm not taking that back home. So by show of hands, who's heard of Varnish Software, the company I work for? I see a couple of hands. Yeah, great, wonderful. Usually when there's not a lot of hands in the air, I say room for improvement or the ideal audience to talk to. Just to summarize what we do, we're a company that builds software-defined web acceleration and content delivery solutions. Very strong emphasis on software. We make the web faster, you install it wherever you want, and get going. But if you're curious, if you ask, yes, we're also the company behind a very popular open source project, Varnish Cache. And most of what I'll present today is 100% applicable using Varnish Cache. So let's talk about a very typical interaction pattern between a user and a server. The direct interaction pattern. User talks to server, server responds back. Still with me on that one? If you're already lost it, then there's no going back. This is as simple as it gets. But the problem is that the server can be under tremendous pressure if Either the concurrency increases, so all that traffic is heading your way, or the type of content that is requested is highly compute intensive. So we position ourselves bang in the middle. We assume the role of a reverse caching proxy. So reverse caching proxy, do I need to go into the term? Yes or no? We're good with it? Yeah, just very short proxy. We're sitting in between user and server, acting on behalf of the server. Caching, what we do is store the responses. Reverse, we're not there to make it faster for the user directly. Indirectly we are, but our role is to protect the server. That's it. And there's different kinds of caching. I just want to emphasize that we're doing HTTP caching. And the fun fact is that HTTP has its own HTTP caching mechanisms. We adhere to those. Things like, very simple, right? Public max H500 to say that everyone can cache this browser and intermediary caches is like ourselves for 500 seconds. The opposite side of the spectrum would be to admit something like this. Now, of course, you might be complaining, yes, there's a lot of nuance to it. Yes, there's nuance to the difference between private and no cache and no store, but this is not the talk for it. I have a separate talk called HTTP headers that make your website go faster. That is not it. The point I'm trying to make is that Varnish adheres to the standards, supports it, making it easy for you to swap out your CDN, swap in a Varnish, and still have the same behavior, more or less. And that applies to very simple things, like an HTML page that's static, some imagery, CSS, JavaScript, very static things. Things get rather complicated, and that's the topic of today, when state starts getting introduced, like when cookies are there. And out of the box, Varnish does not cache when it sees a cookie. Nor does it cache when it sees an authorization header, funnily enough, because the data that is presented there is implied to be highly personalized for your eyes only. So we don't cache it. It's a very defensive, conservative approach, but it's a good one, to be honest, because there's famous war stories, right, of the guy who had his tax returns in the cache and everyone saw his tax returns. We don't want to get into that. I had my fair share of misery in my previous career when I optimized and varnished a website for a popular Belgian festival, and I was a bit too aggressive on the caching on the ticketing platform. Not a good day. Standard behavior is don't cache, which brings this entire presentation, this entire talk to a screeching halt, because we have to reflect on what I just said. And I'll do that. I'm building up the drama, as you can feel, right? I'm going to do a statement, I'm going to ask a question, and we'll come to the conclusion. The statement is, Varnish does not cache when there's cookies. Statement. Question. Who here knows websites, and I'll again try to blind the light here, who uses or knows a website that doesn't use cookies in the modern day and age? I see no hands being raised. Big surprise. Can we come to the conclusion then that Varnish is not built for the real world because everyone uses cookies and Varnish can't handle cookies out of the box? Obviously not. Obviously not. That's a defensive, out-of-the-box approach. You can be much more opinionated and deliberate by using our built-in programming language called VCL, Varnish Configuration Language. And it allows you to pretty much extend that and use cookies in a specific way, as well as other mechanisms. So it's a domain-specific language. With that, I mean it's only applicable to the domain of Varnish. I've seen no use cases yet of using VCL anywhere else, nor am I expecting to see it ever. It's a curly braces language. So if you're into the C style of programming language, you'll feel comfortable with that. What it does, it's built for caching, so it handles requests, deals with responses, can manipulate content, can select backends, can control every aspect of the caching, and pretty much qualifies as an edge compute language, if you will. The reason why a lot of people like it is not only the flexibility, but its tremendous performance. It's transpiled into C, compiled to machine code, tied in as a shared object, making it really fast and absolutely not CPU bound. It's not a top-down programming language, so you don't need to define all the behavior. Most of the behavior is already there. You just need to extend it by hooking into the famous, or infamous, if you will, finite state machine. When I do Varnish presentations, I typically spend half an hour on this. The counter shows that I have 15 minutes left. Let's not make a big fuss out of it. You've seen your fair share of these kinds of diagrams. You know how to read a flowchart. But what is important is all the boxes represent states that we can extend. And they're named in a specific way, like VCL Reg V, which is the VCL subroutine that impacts how requests are received. And based on the actions that you take, you can follow paths. I color-coded them. So if you follow the green path, if you receive a request and it's deemed cacheable, we're going to create a hash to look it up in the cache. The hash is composed out of the URL and the host header. It looks it up in cache, and if it has a hit on the left-hand side, it follows the green path and delivers the cached response, and you're done. ideal scenario. You could be in a situation where whatever you're looking up is not stored in the cache, and then we'll follow the blue path from VCL hash. We've looked it up, it wasn't found, miss, and then we go into the big gray box of horror, which is connecting to the backend. And that's what we're trying to avoid with the cache, but it still is there. So you can fetch content, so that means prepping whatever request you're going to send, which by default is a copy of the incoming request, and then you either get a response prior to storing it in the cache, or you get an error and you don't cache it at all. That being said, here's a simple example that uses that logic. I'm using insanely simple logic here. We define a backend that is hosted on the local host. We might have renamed the port to port from port 80 to 8080, and we're hooking into VCL receive. We intercept the request for the admin pages. We match it to a regular expression, so we use a tilde to do that. And if we're on the admin page or a subordinate resource of /admin, we know there's going to be cookie use. We know it's going to be highly personalized, and we'll bypass the cache. And under all other circumstances, we don't need the cookies. It's static. We strip it off and fall back on standard behavior. Very simple. And this is what is impacted. We go from receive to pass. We can mess around with different aspects. Like when you're in VCL backend response, it means you've sent a request to the backend, so it wasn't served from the cache. And prior to storing it in the cache, you'll make some decisions. Decisions like checking out the content type based on the HTTP response headers. So you have a backend response object, it has an HTTP object, and that contains all the headers. Content type is one of them. If it matches a regular expression that starts with image or video and then a slash, then it's a static image or video, and we're going to cache it for a lot longer than the cache control might imply. So we're going to cache it for a year and overwrite the cache control header that we're going to send to the browser because Google likes that from a lighthouse perspective. And under all other circumstances, we're just going to cache an hour. We're impacting this subroutine. And we can play around with cookies, and here's where it gets interesting. I've presented cookie as some sort of nemesis, but it's not really the case. Because cookies are always there, we might as well get along and be opinionated. The opinionated aspect I showed at first was looking at URL patterns and figuring out, is cookie usage happening there, yes or no? You can completely disregard the URL aspect of it and deal with cookies on an individual basis. Most of the cookies we see in this day and age are tracking cookies. They're processed by tools like a Google Analytics or a HubSpot or all the other crap that lives out there. It is not processed by the server. The server does not care about it at all. It's the JavaScript code in your browser. So we strip it off. We strip all of it off. So what we do is if we see a cookie header, we take the cookie header, we throw it into the cookie module, we parse it, and we throw every single cookie away except that PHP session ID cookie that you might need after you've logged into your admin panel. If it remains there, we'll keep it and we'll write the string back to the cookie header. And if in the end, the cookie is nothing more than a selection of white space characters, trim the cookie, we don't need it. And that way we'll definitely fall back on standard behavior. We'll either cache or not cache. But if the PHP session cookie is there, we won't cache. Which could take us another route as well. Rather than deciding on the cacheability based on a cookie, why don't we embrace the cookie value and use it to create cache variations? Here's an example of a very straightforward use case where you might have a multilingual website that uses cookies. You go to a splash page, select your language region, you click, it stores the value in the cookie, and then you grab the cookie. You remove all the other ones, just keep language. And instead of falling back on standard behavior, we will do an explicit return hash, meaning we will look it up in the cache regardless whether the cookie is there or not. But we'll extend the hash, and this is where we go to VCL hash, which, as I explained, uses the URL and the host header. But in this case, we'll attach the language to it, but only the languages that we support. So if the language is either Dutch, French, or German, then use that, attach it. If it's any other language, fall back to English. And that way, and here's a visual representation of this, you can have, for example.com homepage, an English version and a Dutch version, having two separate variants in the cache. If you'd use the accept language header in the browser, which some websites do, some don't, you could just send a vary header and say vary accept language. That would also work. So again, we've hooked into VCL receive and VCL hash. Here's the next piece of challenging content. Say that your website is cacheable for 99%. You have that annoying 1% that's left there under the form of a header that gives you the shopping cart or that really annoying welcome Thijs, and you click and you go to your profile, highly stateful. Because it is returned as a single HTTP response, the common denominator is not the cache. So despite having 99% static and cacheable data, you're still screwed. How do we tackle that? You can use placeholders to separate cacheable from non-cacheable content and actually split up the single HTTP response into multiple ones. The type of placeholder that a lot of people use and have been using for more than a decade is Ajax. Just say, hey, browser, you deal with it. I don't want to deal with it. I'm not that big of a fan of it, and I'm going to present a feature that Varnish supports and other caches do as well, which is edge side includes. Who's heard of that? Ooh, very limited people. Who's heard of server side includes from back in the day? We're the old-time sysadmins. Also very limited. Okay, let's throw it in directly. This is an XHTML style tag that you put in your code and that Varnish will parse. It could also be applied in non-HTML context. You could throw it into a JSON API or whatever. But it mentions a source attribute and Varnish will stitch that together. It will load the header, parse the content into the main page, and ensure that it's there. And you do that by enabling the ESI filter in VCL backend response. So in the backend response, you can start filtering out those ESI tags. But I wouldn't do it unconditionally. While Varnish is not CPU bound, this might increase the CPU usage a bit. So I'm a big fan of two-step negotiation. And this is not a standard we invented. This is W3C kind of stuff. There is a thing called a surrogate capability header that you can use to advocate the capabilities you have as a cache. So I would say, hey, I have ESI support. And it's up to the application developer to read that header. And if it sees that header, it could take over control and return a surrogate control header and emit ESI. If the surrogate control header is not there, we don't do ESI parsing. Which brings us to the following ESI code. You announce in the fetch, so that's a request header you send to the backend, hey, I can handle ESI. If the application reads that and says, good, I'll send you ESI, you look for the surrogate control header, enable the streaming, and you're good to go. Resulting in this in your HTML code maybe. So everything's cacheable except that header. And you as a user will get a single response with welcome Thijs. There's no browser mumbo jumbo coming into play. There's no doing different requests on Ajax. None of that. Comes as a single HTTP response behind the scenes. You handle it. You don't handle it on the server. You handle it on the edge, which is the outer tier of your content platform, typically represented by either CDNs or by caches like ours, which pretty much perform the same role. Status update time. We've removed unwanted cookies, leveraged cookies for cache variations, and used placeholders to load stateful content. All good. Problem is, or might be, that even the non-cacheable routes, that 5% that's left of our 95% hit rate, might still cause us a little bit of headaches, high server load latency, which requires us to shift gears and go from a serving content on the edge to actually computing content on the edge. I'll stay short about this one. You can actually do authentication on the edge. That would typically happen on the origin. You can use a module called basic auth, check the authorization header, and then load an passwd file and check, is that user allowed or not? You strip off the header in the end, remember caching behavior, and be done with it. That's a very basic one. Is this useful? To some extent, but this was a lead-in to actually ask the question, but what about JSON web tokens, right? What do you want to do with those bad boys? We can handle them as well. For those who don't know what a JSON web token is, this is a colorized version of it. As you can see, it consists of 3 parts, dot separated, and each part is nothing more than base64 encoded JSON. Could be used for authorization, that token. There's header, which is in red. There's payload, which is in the pinkish color. And blue is the signature. The signature assures the cryptographic security of the payload itself. Because if you decode it, you will see that the header just returns the algorithm, which is an HMAC or has an HMAC signature hashed with SHA-256. And it's a JSON web token. Then you have your actual data, which we try to keep short. It consists of claims. Some of them are conventional. We try to keep them as minimized as possible because the bigger the string, the bigger the size of the response over the var. We have a subject, a name, an issued at, timestamp, and an expiration. Varnish can verify that and can validate that and can also create that signature because the signature provides security that the content hasn't been tampered with because it uses the header and the payload and HMACs it using a secret key. So if whatever signature you receive is not the one you'd expect, then you know it's an invalid one. Typically gets sent using something like this, a bearer authentication token, where the token fits in here. Now I need to warn you about explicit content coming up. Explicit being lots of ugly regular expressions. I want to warn you about that one. It's pretty ugly. But the idea is that we extract or match the authorization header and see whether it fits the format. If it doesn't fit the format, we'll stop execution straight away. If it does, we'll get the header And from the header, because the header is nothing more than the first group of the token that we extract with the regsub function, from that header, we'll do a base64 URL decode. So we'll decode the content, look into the string, match the header, look for the TYP property and get its value. We'll do the same for the algorithm, by the way. And then we can do a comparison a bit lower in the if statement. If the type isn't JWT and the algorithm isn't HS256, something's wrong with the header, stop execution 403. If we're past that, we can actually take the raw payload, which is the second group of the token. We can also take the signature, which is the third one in the group. And once we've done that, we can actually start estimating or actually calculating whether that signature is correct. So if we know what the signature is we received, and we know the payload, and we know the header, we can stitch them together and do a base64 URL notepad hex of the HMAC signature we create. The only thing we need, of course, is the header, concatenation with the dot and the payload, and a secret key. The secret key is uninspiringly named secret. I wouldn't put that in a string if I were you. I would load that from a file that is secure. I would roll it over. But that's the way you could validate the hash. And if those signatures don't match, obviously someone tampered with the data and you can't let them in. And in the next step, we actually take the payload by base64 URL decoding the raw payload, extract the expiration time, extract the username, and do a final check whether or not the token has expired. And that's how you do that. I know it was a little bit of a hassle. We actually built, in Varnish Enterprise, built a module for that turns all that code into this. Pretty easy, right? Pretty easy. You just take the first, or you take the entire token, give it the secret, give it the algorithm we need to match it to, and then it's true or false. Straightforward. You've seen a lot of those. This is synthetic responses. Synthetic responses are responses that did not originate from the origin. So this is us returning it. And if we would do synt 200, you'll get 200 OK. You can change OK into hello world if you want by altering the second version. And this fits into VCL synt. That's, you can go from different stages to VCL synt. The problem with that is, or being, this is the output you'll get. And you've probably seen that on websites that were failing. This is not Varnish that is failing. If you see Guru Meditation, it's not Varnish that is failing, it's the backend that's failing. Or some synthetic response that was returned. I'm not a huge fan of the format, to be honest. You can change it. You can change the template in VCL synt and remove the entire HTML interpolation template and put your own content there, which we will do in one of the final examples to do a very advanced use case where we will return personalized data via synthetic responses. Imagine this use case. You have a /API/session, highly personalized, and still you want to serve it from the cache. You would have an authorization, a bearer authentication token, or a simple session cookie. We'll use a simple session cookie for now to generate very specific session output in a JSON format. This being it. The goal here in this example is to compute that 100% in Varnish without accessing the origin, because the origin would be very sensitive to all that type of traffic. What we'll do here is we'll fetch the sessions directly from the session storage, which could be a Redis key value store. And if you do, you can use this free and open source libvmod Redis provided by Carlos Abalde. The way we approach this is hypothetical, of course, is if you would be in Redis, you would do exists of your session key. And if it returns 1, we already know the key is there, so you're logged in. But we also want to have the properties. So you can do an get in Redis, which would get the hash with multiple properties. The property being logged in and items in cart. Logged in true, items in cart 5. Typically, you need some application code to handle that. What I would do is write the following VCL to do that. It gets a little bit ugly, but it's all manageable, right? You need the Redis vmod and the cookie vmod. VCL init is a subroutine we use when Varnish starts. It has nothing to do with incoming requests, but it allows us to already set up the Redis connection using the connection string. We intercept any request for API session, get the cookie, check whether or not it has the session ID cookie. If it doesn't, you're not allowed in. If it does, we'll store the value in the session ID request header and return synthetic output. In about 4 seconds, this beeper is going to go off. We're almost there. 1 second, done. No beeper. Big surprise. So the 200 OK isn't what you're going to get here. We're going to intercept that. And again, we're going to intercept in VCL synt API session and we'll run all the Redis code. Redis code being check if the session key exists. If it doesn't, we'll return a 404 JSON ourselves. If it does exist, get the logged in items or logged in property and the items in cart and parse them into JSON here. And that way you can do highly sophisticated logic on the edge without even interacting with the origin code. making it super fast as long as Redis can keep up. Am I saying here that you should move all your application code to the edge? No, but pick and choose and see what hurts you the most. We've heard a lot about observability. We'll use those tools to figure out what is causing the most server load and maybe take some isolated use cases and move them to the edge to vastly accelerate your performance. And before I leave you, this is the last nugget piece of information. We're working on an engine where you can do that beyond VCL and use WebAssembly as a format. For those of you who don't know, WebAssembly is a byte or an instruction set, a bytecode format built for the web and allowing users to compile codes into that format and run it in the web. It was originally invented to run in browsers, to run non-JavaScript code in browsers. But we can run it, like many others, on the edge, allowing you to personalize the cache using other languages. We've created a project called Sledgehammer, which is still in research, already in development, to be honest. It's past research, it's already in development. I could do a sort of a tech preview, but I can't give it to you. It's not out there yet. But it loads WASM in Varnish. And the big disclaimer is, of course, everything you'll see is experimental. So if you bear with me, maybe 30 more seconds we'll get through it. This is an HLS video playlist. This is also HTTP. It's not web, but it's a video playlist. I went to a trade show in the Netherlands, a big one called IVC, which is all about media and streaming, and you'd be surprised how popular these delivery tools are. So what we're going to do is, this is the Big Bug Bunny. For those of you who are in the know, it's the most famous open source video that is out there. It has different video segments, and what we're going to do is we're going to inject ads into it based on the browser language. And we'll do that in JavaScript. So first you need to prime Varnish and say, we're going to load WASM. It's going to live in that file. The JavaScript is going to be there. The WASM runtime is going to be there, and we're going to execute that in the stages. And here's the code. This is plain old JavaScript code, and we can actually leverage the entire NPM ecosystem to load in dependencies, being a module that checks the browser language or an M3U8 parser. We do a getLang function that takes the event, the request event, extract the language, choose which language we want, hook into the deliver process, set a response callback, parse the M3U8 file with the input, queue in the ads, use the browser language and the bitrate, and send it back. It's as simple as that. That is how we see things moving forward, using tools that are out there, using technologies that developers know, and it's as simple as doing WASM build and Varnish reload. You'll hear me talk about that more next year, later this year. Thanks for sticking around. I still owe you a book. It's over there. Nature will sort it out. First come, first served. Thank you for sticking around. It was an absolute pleasure to be here with you. Thanks.